All right, so this is 3-1. Y'all, 3-1 is my favorite, and it's because we finally get to get into quadratics. The idea here is that you're all in college algebra. You hopefully have had at least 2 algebra courses prior to this, whether they were in high school, and that was a really long time ago, or high school, you're still in high school. Algebra 1 and Algebra 2 are the foundational pieces to college algebra. So a lot of what we're going to talk about today should be review. Now, if you are, you know, older in age or whatever, or you've taken Algebra 1 and Algebra 2 so long ago that you don't even remember, then no worries. I will explain it on a level that you can understand. However, because of a time constraint, I won't be able to go into deep detail as to how and why things work the way they work. If you are struggling and you need more help foundationally, let me know and I will send you some YouTube videos from other instructors that may be helpful to build up that foundational knowledge that you might be lacking. So if there's something that we talk about and you're like, oh my God, I don't remember that, no worries. Send me a message and I'll send you a direct video that can help to remind you of those things. All right, I'm going to put my screen down so you won't see me, but you can hear me. The first thing is just being able to identify what a quadratic function is. Quadratic functions are written in the form f of x equals ax squared plus bx plus c. Ax squared plus bx plus c lets us know that it's quadratic because the highest exponent is a 2. That is what we call a quadratic function. If the highest highest exponent was a 1, then that's called a linear function. And this one's quadratic. Also, you could have f of x equal ax cubed plus bx squared plus cx plus d. This would be, anybody remember what that one's called? With the little 3? All right, it's cubic. And then a 4 is quartic. And then a 5 is quintic. But we're not going that far. You don't have to worry about that right now. We're going to talk about quadratic today. So as long as it has the highest exponent being a 2 in a polynomial, then we are good to go. Now you have to be leery, okay? A little bit leery here. If the squared function or the square is in the denominator, it is not a quadratic. Because if it's in the denominator, we remember our exponent rules from algebra 2. That actually means that if it were brought up to the numerator, it would be x to the negative 2 power, and that's not a quadratic. So if it's in the denominator, that is not quadratic. That is part C, y'all. C is neither linear nor quadratic, and that's because it's in the denominator. So that's important to note. It has to be able to be written as ax squared plus bx plus c, where the ax squared is actually in the numerator or written out as a true polynomial. So if you need a refresher on what a polynomial is, then I can, send you a video on that. So let's do this really quickly. Part 1A. What kind of function is that?
Cubic?
Yes, good job. Thank you. Being able to identify why and how these functions are a part of their families is going to be important. So this is a cubic. So it's neither linear nor quadratic. B is going to be linear. And we know that because the highest exponent is a 1. Whereas D is going to be quadratic. And we know that because the highest exponent is a 2. If you are lost right now, I need you to chat me and let me know so that I can help you. And I know that I need to be able to send you some foundational videos. Now, it says if it is quadratic, we actually want to solve. So it says solve or evaluate rather f of negative 2. What that means is we're going to just put in negative 2 wherever there's an x. X minus 5 times negative 2 minus 3 times negative 2 squared. With order of operations, we know we do the exponents first. So that'll be -3 times 4, because -2 times -2 is +4. And then we just work from left to right. 2 minus, plus 10, because -5 and -2 make a +10. And then minus 12. So this is 12 minus 12, which does give us 0. So f of -2 is 0. In other words, there's a coordinate point on that graph that is -2, 0. Any questions about that? That is number 1. Can you identify a quadratic equation and know the difference between quadratic and linear? Okay. This next part is pretty cool because it allows us to know some new vocabulary words. These aren't really new. Again, they're from Algebra 2 and Algebra 1, but it's just a little refresher. All quadratics are the shape of a parabola. If you say parabola, that means we know you ain't a math person. So let me not catch y'all saying parabola. It's a parabola. And parabolas can either be smiling up like a cup, or frowning down like a frown. We only know if it's going to be up like a cup or down like a frown based on the leading coefficient. The leading coefficient is the A value. The A value, in short, is basically the number in front of the x squared term. It's attached to the x squared term. So you're going to look at this and you're going to say, what is my A value? If your A value is positive, your parabola is going to be smiling up like a cup. If the A value is negative, it's going to be down like a frown. Now, if it's up like a cup, there's going to be a bottom, like a valley. There's going to be a bottom point. We call this point the minimum. It's also called the vertex. It's the lowest point on the graph. Now, the vertex helps us to know one other part, and that's called the axis of symmetry. Okay, I got a lot of people in the waiting room. Hold on. The axis of symmetry basically cuts the parabola in half. It always goes through the vertex. Axis of symmetry goes through the vertex. The axis of symmetry goes through the vertex, no matter if it's up or down. Okay. So in this case, we have another vertex, but this time, if this one's called a minimum, what do you think this one is called right here where I'm highlighting?
That's the maximum.
Maximum, yes. It is called a maximum. And that's because it's the highest point on a graph. So when the vertex is at the top of the graph, or in other words, the A value is negative, it flips that parabola upside down, it's going to have a highest value, which we call the maximum. Let's put a little practice here. Example 2 shows us a graph. Where is the vertex on this graph? It's right here. The vertex is 3, 1. The axis of symmetry goes through the vertex. It's going to go straight through. It's always going to be the x value of the vertex. So the axis of symmetry is x equals 3. No matter what the vertex is, the axis of symmetry is its x value. I don't usually make universal statements like this in math, but here I can. The axis of symmetry is always the x value of the vertex. You find the vertex, you already know where the axis of symmetry is. Any questions about that? Okay. Because I teach 2 classes back to back, I'm about to eat an apple, so hopefully it doesn't sound ridiculous on the recording. Here we go. Axis of symmetry, x equal 3, vertex 3, 1 tells you exactly where on that axis that vertex lies. And then we also know that this is smiling. So my a value is greater than 0. My a value is positive. That's what we know. All right, there's more that the a value will tell us. It won't just tell you if it's up like a cup or down like a frown. It'll actually tell you the width of your graph. So y equals x squared is your parent function. It just looks just like that. Like it is what it is. X squared. 2 squared is 4. 3 squared is 9. 4 squared is 16. That's going to be your normal perfect squares. So if you put this on a coordinate plane, 0, 0, 1, 1, 2, 4, 3, 9, and vice versa. Negative 1, 1. Negative 2 squared is 4. Negative 3 squared is 9. Y'all see that symmetry? Now, if I were to take my values and multiply them by a factor that is greater than 1, let's say I doubled it. Like I wanted to multiply it by 2. That means that my graph is going to shoot up faster. So it's not going to be 1, 1. It's going to be 1, 2. 2 won't match to 4. 2 will match to 8 because 2 squared is 4, but then you have to double it. 3 squared is 9, but then you have to double it. So it's all the way up at 18. So it makes it narrower. The larger absolute A is, the narrower the graph. Because we're making it grow a lot faster by multiplying it by a whole number. Now, the smaller A is, like half of it or a third of it or an eighth of it, that means that we're taking those numbers and we're making them smaller and smaller. So the wider the graph. So basically, let's say we took 1, 1. Then we took half of it, that'd be 1, 1 half. Then half of 4 would be 2. Then half of 9 would be 4.5. So you can see how those graph is going to go a lot slower in terms of growth. So that's why the graph is wider when you're multiplying by a fraction, because you're taking a fraction of the output for your new output. Does anyone have questions on that? All right, let's get to it. We're going to determine if these graphs are narrower or wider. The very first thing, and I want you to get accustomed to doing this because you're going to do it all day today. The very first thing I want you to do is write this in standard form. Ax squared plus bx plus c. Every problem, make sure you write it in that form. So for this one, we'll have negative 6x squared minus 4x plus 2. We're only interested in the a value right now. So we have a equal negative 6. And because it is negative, we know it opens downward. Okay? Now look at the absolute of negative 6 is just 6. 6 is greater than 1. Therefore, it's narrower. It's growing fast, fast, fast. It's growing by a factor of 6. So instead of 3 mapping to 9, 3 is going to now map to 54. That's way higher. So our graph is narrower. All right. This one is already in standard form, so we can identify A as 1/3. It opens upward because it is positive. Now, absolute 1/3 is 1/3, and that's less than 1. So that means this graph is going to be wider than the parent function. Any questions on that? Take a moment to try part A, number 4. Can you find out as much as you can? When you've figured out as much as you can, write in the chat and tell me that you're done. And then I'll start talking again. Get started on it. Does anyone want to tell me what they got for any of it? Just to see if it's right?
I got the vertex was 3, -4.
On which one?
Sorry, are we doing example 4A?
Yes.
Sorry, -4, 3
Okay.
for the vertex.
That is correct. -4, 1, 2, 3, 4, and up 1, 2, 3. So -4, 3. Perfect. So we automatically know the axis of symmetry, which is what, David?
It is -4.
X equal -4. So for the axis of symmetry, it is a line. So we want to give it its name. We have to name it as x equals -4. That's good to know. The sign of the leading coefficient, is this a positive graph or a negative graph?
It's a negative graph because it's pointing downward.
Negative because it's downward. Look at you giving us reasoning as well. Downward. Okay. Now, the axis of symmetry is really cool because it allows us to identify the space where our graph is going to change direction. So our graph from left to right is increasing until it gets to -4. So increasing from -infinity to -4. And then it begins on its journey downward. So because of that, we can say it's decreasing from -4 to infinity. Notice that I don't have any brackets here because we don't know what's happening at -4. It's neither increasing nor decreasing. So we cannot include -4 in that set. The range and the domain, however, are pretty straightforward. I will tell you this. The range of a quadratic, the domain of a quadratic is usually all real numbers because there aren't any denominators and there aren't any square roots. So we don't have any restrictions on the domain. Remember I told y'all last week, if you're looking for the domain of anything, you have to look for two things. Is there a square root? If so, it has to be positive. Is there a radical? Is there a denominator? If so, it can never be 0. Those are the only two things that will give us a restriction in a domain. And because we don't have those in a polynomial quadratic, we are here with all real numbers, written in interval notation, -infinity to +infinity. The range, however, we always start from the bottom and go to the top. I was teaching at the time of like a Drake era where Drake had a song started from the bottom, now we here. We use that to find range all the time. What is the bottom of this graph? Well, Dr. Taylor, there is no bottom because it's arrows. So that means it's -infinity. Where's the top of the graph? Well, the top, this graph will never pass this line of y equal 3. So our range goes from -infinity to 3. But we are going to include 3 because it does touch 3. All righty. Let us move forward. I'm going to do this one really quick, just in demonstration format. Just double check and make sure that you got it right. I know for sure that this is a positive graph because it opens upward, has a positive leading coefficient. When I notice that my vertex is a minimum, it's going to be located at 0, 3, which means that my axis of symmetry is x equals 0, aka the y-axis. I am increasing on this side of everything, so from 0 forward. I am decreasing, however, from -infinity towards 0. The domain, all real numbers, there's no restrictions. And the range started from the bottom, now we here. The bottom here, we have it is -3. Sorry, I just realized I wrote the vertex wrong. It's 0, -3. But the range here is -3 all the way to positive infinity because there is no cap. All the way up. Any questions? Life is good. If you can do this, then you're going to question on the test already right. Are you sure you don't have any questions? This will be a question on the test. All right, moving forward. Now, I know y'all are like, oh my goodness, we have so many equations to learn. You have your y equals mx plus b, which was your linear function. And then we learned it a little bit differently to learn how to write it in point slope form, right? Well, now we have our quadratic formula. That's ax squared plus bx plus c. And we're going to learn how to write it in vertex form. Now, I want you to see me write this, and I want you to be able to tell me what is similar to between these two equations. What is similar between these two equations?
It looks like it's the same format, but there's the power of 2.
It is the exact same formula. All we're doing is looking at the growth factors with different letters. So instead of an m being our slope rate of change, we're looking at a leading coefficient of a. They basically are doing the same thing, but they represent themselves differently because they're a different family of functions. We talk about this one in terms of x and y, and then we talk about this one in terms of h and k. H and k is literally just x, y, but it's hk because of conics and all these reasons that mathematicians made this bullshit up. But I'm recording. Oh my God, I should not have said that. That's horrible. Anywho, the mathematicians made these things up. HK is a conic, and they just represent basically XY. I definitely cannot post this on YouTube now. Shame on me. Anywho, so what we're going to do is we're going to look at X and Y in terms of H and K. So HK is going to represent the X value of the vertex, and K is going to represent the Y value of the vertex. It's really easy to find these values when we're given our standard form. So if we're given standard form, what we're going to need to have is an idea of what is A, what is B, and what is C. To find H, what we're going to do is we're going to say negative B over 2A. To find K, we're basically going to take our function and substitute in H. So all we have to do is find H first and then substitute that into the function, and that'll give us our output. So without like just talking about math, let's do it. So A is equal to -1/2. B is equal to 3. C is equal to -4. Okay. We need to find the vertex. So H is given by negative B over 2A. -3 over 2 times -1/2. So that's -3 over -1, which is +3. So the vertex is 3 comma something. Well, to find out that's something, all we have to do is substitute in 3. Okay. So 1/2 of 9 plus 27. Oh, I'm sorry, I keep doing that. Plus 9 minus 4. So this is -4.5. So that'd be -8.5 plus 9, which is equal to 0.5. So 0.5 would be our Y value. Now, because we know our vertex, we know our axis of symmetry. So the axis of symmetry is happening right here at x equals 3. That means, oh, we also know the directionality of our graph. This is a negative graph. So that means our graph is going to be going up and then down. It's going to have a frown. So when we talk to increasing, it's increasing from negative infinity to 3. And it's going back down from 3 to positive infinity. Now I'll tell you how I knew that one more time. The A value is negative. So that means it's opening downward. The vertex happens at 305. So therefore the x equal 3 is the axis of symmetry, which is going to tell us where our graph is going to change from increasing to decreasing. And that's it. Any questions on that? So these problems are the exact same. I want you to find the minimum or the maximum. When it's asking you for the minimum or the maximum, it's just asking you for the y value of the vertex. The vertex x value tells you where it occurs. And then the y value tells you how high or low it is. So the minimum, it says find the vertex y value. So we're going to say A equal 3, B equal -2, C equal -5. For the vertex, we're going to say H is equal to negative B over 2A. So negative -2 over 2 times 3. So that's 2 over 6, which is 1/3. Okay. And then what you have to do is take your function and substitute it in. So 1/3 squared is going to be, is it 1/3 or 2/3? What did I do wrong? Oh, I did it wrong the first time. Okay, so that's 3 times 1/9 minus 2/3 minus 5. So that's 3/9. And I'm going to not change this from ninths. I'm just going to change this from 2/9. So 3 minus 4 is -1/9 minus 5. Did I do anything wrong there? I don't think so, but let me show y'all something. Let's say you're taking a test and you're like, that looks weird. What do I do? What did I do wrong? All you have to do is go into your Desmos. And then we're going to type it in. Y equals 3x squared minus 2x minus 5. And there it is. Our really, can't get it out. Our vertex really is at 1/3, comma -5 1/3. but something is wrong here. So let me fix it because I'm a little bit confused as to what I did wrong. Instead of taking that to 4/9, I could have easily just did this the right way. 3/9 minus 2/3 minus 5. 3/9 is just 1/3. 1/3 minus 2/3 is negative 1/3. And 1/3 minus negative 1/3 minus 5 is negative 5 and 1/3. And that's your output. Okay. All right, we want to do it for number 8 as well. Can you all try that one on your own and see if you get it? So if you're watching this video, just pause it. Here live in class, we're gonna just pause talking and then we will resume. All right, y'all. So I just did a little bit of the work here, and the maximum I found to be y equals 11. And in the first one, they were asking us for the minimum, so I just wrote it out. The minimum was y equals negative 5 1/3. So the first thing that I did, and I realized I got hooked up on it, was I went and said that A was 8 and B was -2, but that is not the case. That was a trick. That's going to be on the test too. I don't want to trick you. I want you to know that the A value is the one that's attached to the x squared. So rewrite it in order for you to know that just because it's first doesn't mean that it's A. And make sure you do that. Anybody else make that mistake? Oh, okay, y'all smarter than me. I ain't mad at it. Okay, so yeah, just figuring it out that way, figuring out your x value, then substituting that x value in to be able to solve for your y value. When it asks you for the maximum or the minimum, again, it's just looking for the y value of the vertex. And you could type this into Desmos during your test just to verify that you really got the right vertex. There's no reason you should get it wrong if you can verify with Desmos, and Desmos is available. All right, this is just a sketch of the graph, so it's not going to be anything special. It's basically saying the vertex here is 3, 1. That's because that's HK in this form. The axis of symmetry is x equals 3. The parabola opens downward. So 3, 1 vertex, and the parabola opens downward. That's all I'm looking for. Not asking you to do too much, just a sketch. And that little ugly drawing that I have there is good enough. Any questions? All right, so to complete 3.1, we're gonna look at some application problems. I'm gonna put a star by this one because I can guarantee you're gonna see it again. Now, I'm gonna explain it. We have a fence that's basically making a rectangle, but one side is missing because we are using the river as a natural side for this this cattle fence. So we're gonna use 1,800 feet of fencing to build this little rectangular area. So we're gonna use one length. Usually we'd have two, but of course we're using the river. So we have one length and another width here and one more width over here. That's gonna total 1,800 feet of fence. Are there any questions where I got that from? It's like the perimeter, but we're just not using anything to represent the riverside because we don't actually need material over there. Now, it says find the maximum area for the cattle. The area of this rectangle is what we want to maximize. So if the area of a rectangle is represented by length times width, we need to try to figure out how can we solve this equation to maximize the area. This goes back to what we talked about last week. We do not want to have two variables in one equation because we can't solve that. So we're going to use this equation to rewrite the length in terms of the width. So for example, the length plus 2 widths equal 1,800 feet of fencing. If I wanted to know exactly how much fencing I'm going to use for my length, all I would do is take my 1,800 feet of fencing and take away the part I'm going to use for the width. And that would leave me with what the length is supposed to be. So length in essence can be represented by 1,800 minus 2 widths. That's going to tell me what's left over. This is the example from last week when I said, hey, I got 5 pieces of candy. My son and my nephew are here. I'm going to give my son some, and I'm going to give my nephew the rest. How can you tell how many I gave my nephew? Well, it's whatever I didn't give my son. So it'd be 5 minus son. In this case, how much is left on the length? Whatever you didn't use on the width. So 1,800 minus the width will give you the length. So I'm going to take my area and I'm going to equal it to 1,800 minus 2W times the width. This is still length times width problem. I'm just replacing the length with 1,800 minus 2W. I have one equation now and one unknown. This is the beauty of that. One equation and one unknown. So when we solve this, we're going to solve for the width. And then we're just going to work backwards and say, okay, that times 2 minus 1,800 is going to give us how much we did on width. So this is a little weird, but it's just a distributive property. All you have to do is multiply the W by both things. So we have area is equal to 1,800 W minus 2W squared. Rewrite it so that it's in quadratic form. And then we can find the maximum area. So all we have to do is find the maximum, that's the vertex, remember? Because this is an upside down parabola, we find out the maximum at the vertex. So let's find the vertex. It's negative b over 2a. So in this case, it's negative 1,800 divided by 2 times negative 2, because a is negative 2, b is 1,800. And that is going to give us 450. That is our W. The width is 450 feet. You got 450 on one side, 450 on the other side. How much is the length? It's 1,800 minus 2 of the widths. So we now know that the length is 900 feet. Okay, so 900 feet with 400 feet. Then they want to talk about what is the area. So remember, area is length times width. So all we have to do is do 900 times 450. And that will tell us that area is 405,000 square feet. If you have a length of 900 and the width of 450, then the total area for the cattle is 405,000 feet, square feet. Do y'all have any questions about this? So basically that maximum allows us to find information. It's pretty straightforward. All right. Last but not least, we have a problem where we're applying the same knowledge of quadratics to baseball. So we have an equation that we've been given. This equation is negative 16 t squared. This is the amount of time that the ball is in the air, plus the velocity, the initial velocity, times time, plus the initial height. So in this case, it says the initial velocity is 96 feet and the initial height is 2 feet. So all we have to do is write that formula. And replace V naught with 96 because that was the initial velocity, and the initial height is 2. So we now have a parabola where we have A, negative 16, B, 96, C, 2. Okay. Says, how high was the baseball after 2 seconds? Well, T is seconds. So all you have to do is put 2 in the equation. Put that in your calculator, you get 130, what is it? Feet. It's 130 feet high. It says find the maximum height. When you see word maximum, you should immediately be thinking vertex. Okay? Because we all know that a ball is going to go, like that's the path of a ball. We know that. Okay? So it's going to be hit, it's going to go up, it's going to come down because of the law of gravity. So at 0 times 0, the ball was 2 feet high already because the pitcher threw it. It wasn't on the ground. It was right there at 2 feet. After 2 seconds, it's at 130. Okay. We got to find out how many, like how long did it take for it to reach its maximum height? So the vertex is important, negative b over 2a. In this case, that's negative 96 divided by 2 times negative 16. Negative 96 divided by negative 32. And that equals 3. So at 3 seconds, how high was the ball? So we just put in 3. S of 3 equals negative 16 times 3 squared plus 96 times 3 plus 2. You put that in the calculator, you get 146 feet. That's the maximum height. Anybody get something different? Okay. So that's going to be our maximum height, 146 feet. It happened at 3 seconds. Now, thinking about what we know that this is the vertex. We know that this is the maximum. We know that this is the axis of symmetry. So if I were to fold my graph, if it took 3 seconds for it to get the highest it was going to be, then we know it's going to take 3 seconds to get back to the ground. So it's going to take 6 seconds total to be in play. So when it says, what is the domain? The never-ending arrows don't make sense in this case. Like, it's not going into the ground, it stops. So therefore, our domain is from 0 to 6. Now, granted, it is a little bit over 6 because it started off 2 feet, so at 6, it would actually be 2 feet above the ground, but 6 point some is when it actually touches the ground. It says estimate, so we're just gonna stop at 6. For the range, our graph is going to be on the ground at some point, but it goes all the way up to 146 feet in the sky. So our maximum on our range is 146 and the minimum is 0. Any questions? Okay. Y'all, that's 3-2. I mean, that's 3-1. Let me pull up the attendance code and get you that for today. And then we're going to go into 3-2. Let me stop the recording so that